In this video, we're going to look at a slightly different version of combination problems that I've decided to call Combinations 2.0. So this is just a little twist on combination questions that I have learned over the years, throw students for a pretty good loop, so I've decided to kind of separate it off and shine a light on it in hopes that it won't cause you guys to stumble too much. Let me write out an example here. Let's say I have 16 cats and 23 dogs. How many ways can I choose 4 cats and 3 dogs to go for a walk with me? Alright, so I sometimes call these slots within slots, because the idea here is, with this problem I have a giant slot for cats and a giant slot for dogs. So to say it differently, we basically, instead of having one thing we're choosing from, we have 2 distinct categories that we're choosing these from. And so I have to choose 4 cats in the cat slot. So within my giant cat slot, I have 4 cats for the different slots, for the different cats that get to go on my walk. And then in the dog slot, I have 3 slots for choosing 3 dogs. So that's kind of what I mean by slots within slots, is like I have categories, and then within those categories I'm choosing individual items for that. Alright, I moved my cats and my dogs label down to give me room to fill in the math here. So this is a combination problem, because in the end all the cats and all the dogs who are chosen get to go on the walk. They're all getting the same outcome. It's not about putting them in a particular order or giving them different jobs. They all get the same outcome. So we're going to fill this in like combinations, and so essentially for each of the bigger categories you do a combination routine. So I'll do a combination routine for the cats, and I'll do a combination routine for the dogs. So, with the 4 cats, I'm choosing from 16, so I have 16 with my first choice, and then 15, and then 14, and then 13. And fundamental counting principle tells me I multiply those up. And since it's a combination, I'm going to divide by the number of slots factorial, because I chose them in a particular order, but the order doesn't actually matter. So that divides out the order. Alright, so that is the cat slot. Now I'm going to do the same thing with the dogs. With the dogs, I have 23 dogs at first, and then 22, and then 21. Multiply those up and divide by 3 factorial. So I have the dogs combination. And then the way this all gets glued together, again using our fundamental counting principle, is we multiply how many different cat choices we have times how many different dog choices we have. And that's the deal with it. So you do the cats as its own combination and the dogs as its own combination, and you multiply it all up. So when I do the cats, I get 1,820 options for that. When I do the dogs, I get 1,771 options for that. And then multiplying all that together, I get 3,223,220, which is something of a fun number there. So that's the idea. Hopefully you can see, and you could have different categories. So we could be talking about, instead of choosing 10 cars for our 10-car garage, we could have 10 cars and 15 trucks. How many ways can we choose 5 cars and 5 trucks to park in our 10-car garage? So that sort of thing. But the idea is you have 2 different categories, and then you're making choices within those categories. I'm going to clear this out and show you the same thing using our combination notation, so you can just see it a little differently, and maybe that'll help it all kind of click into place. It also gives you a good sense of where the notation can come in handy, because these can get kind of unruly as far as how much page space they take up. So basically I have 16 cats and I need to choose 4 of those. So that would be 16C4. And I have 23 dogs and I need to choose 3 of those. So that would be 23C3. And you just put it happy little multiplication symbol between there. And all the numbers calculate out the same. But I just thought I'd switch over and show you that using the combination notation to give you a sense of how it is handy shorthand, to kind of give you something a little smaller to represent your thoughts, and then you can bust it out into the bigger process of calculating it all out. Go ahead and give some of these a try and see how you fare.